NASA deliberately turned off one of the greatest cameras humanity had ever sent into space. And the last thing those cameras saw before they went dark forever changed the way we think about our place in the universe. We are talking about Voyager 1, a spacecraft launched in 1977 that traveled billions of kilometers away from Earth. In February 1990, after completing its planetary encounters, Voyager did something no spacecraft had ever done before. It turned around and looked back toward home. It took a series of 60 images that became known as the Solar System Family Portrait. And shortly after the final images were taken, NASA began shutting down Voyager 1's imaging system permanently. Not because the cameras had failed. Not because of an emergency. But because every watt of electricity mattered. Voyager 1 launched on September 5, 1977, during a rare planetary alignment that allowed the spacecraft to use gravity assists to travel efficiently through the outer solar system. It flew past Jupiter in 1979 and revealed a world far more dynamic than scientists expected. Voyager discovered active volcanoes erupting on Io, photographed the enormous Great Red Spot, and provided detailed views of Europa's fractured icy surface. Then came Saturn in 1980. Voyager 1 revealed astonishing detail in Saturn's rings and showed that the planet's ring system was far more complicated than it appeared from Earth. Titan, Saturn's largest moon, also turned out to possess a thick atmosphere that prevented the spacecraft's cameras from seeing the surface. After Saturn, Voyager 1 was sent onto a trajectory that carried it out of the planetary region of the solar system. Its primary planetary mission was over. But one scientist wanted to do something extraordinary. Carl Sagan, a member of the Voyager imaging team, had argued for years that the spacecraft should turn its cameras toward the planets it had left behind. He wanted Voyager to create a family portrait of the solar system from billions of kilometers away. The idea was not without risks. The cameras had been designed for close planetary encounters and had been inactive for years. Pointing them back toward the inner solar system also meant working near the direction of the Sun, creating the possibility of stray light and damage to the aging imaging system. But NASA eventually approved the plan. In February 1990, engineers carefully powered up Voyager's cameras and prepared the spacecraft for one final photographic sequence. The spacecraft was more than 6 billion kilometers from Earth. At that distance, the planets would not look like the spectacular worlds Voyager had photographed during its flybys. They would appear as tiny points of light. Neptune was barely more than a faint smear. Uranus looked like a ghostly point. Saturn's rings were difficult to distinguish. Jupiter, which had once filled Voyager's cameras with enormous cloud bands and storms, was reduced to a tiny bright dot. Distance had transformed everything. From billions of kilometers away, even giant worlds became almost indistinguishable from stars. Several planets could not be included in the final portrait. Mars was too close to the Sun from Voyager's perspective and was extremely difficult to detect because of its thin crescent phase and scattered sunlight. Mercury was omitted because photographing it would have required pointing the camera dangerously close to the Sun. Pluto was too faint and too small to produce a useful image with Voyager's cameras. Then came Earth. Voyager was approximately 6 billion kilometers away when it photographed our planet. Earth was far smaller than a single pixel on the camera's detector. The spacecraft could not resolve continents, oceans, cities, or clouds individually. Instead, Earth appeared as a tiny point of light. And something remarkable happened. Because of the geometry between Voyager, Earth, and the Sun, scattered sunlight created bright streaks across the image. Earth happened to sit inside one of those rays. That tiny world became the famous pale blue dot. It was not a detailed photograph of Earth. It was something more profound. It showed our entire planet reduced to a tiny speck against the darkness of space. Every human being who had ever lived was somewhere on that tiny world. Every civilization, every war, every discovery, every family, every triumph and tragedy in human history had happened on that single distant point. Carl Sagan later reflected on the image in his book, Pale Blue Dot, explaining how such a distant perspective could remind humanity of both its smallness and its responsibility to protect the only home we currently know. The final image in the sequence was not a dramatic picture of a planet. It was essentially a view dominated by darkness and scattered sunlight. And then Voyager's cameras were finished. The imaging system was shut down because Voyager had a much longer mission ahead. Its radioactive power source was slowly producing less electricity every year. Engineers had to shut down systems that were no longer essential and carefully manage the spacecraft's remaining power. The cameras and their heaters were among the systems that could no longer be justified. Voyager 1 would continue traveling outward. Instead of photographing planets, it would study the environment beyond the solar system using its remaining scientific instruments. Years later, Voyager 1 crossed the heliopause and entered interstellar space, becoming the first spacecraft to do so. The cameras that had photographed Jupiter's storms, Io's volcanoes, Saturn's rains, and Earth's pale blue dot would never take another picture. They remained attached to the spacecraft as it continued into the darkness. Today, Voyager 1 is still traveling through interstellar space, communicating with Earth across an enormous distance using technology designed more than 4 decades ago. Its power is fading, its instruments are being shut down one by one, and eventually the spacecraft will become silent. But the pale blue dot will remain. It is more than a photograph. It is a reminder of scale. From Earth, the universe can feel like something enormous and distant. From Voyager's perspective, the opposite became clear. Our entire world was the tiny thing. The planets we once thought were enormous became dots. And the civilization that built a spacecraft capable of reaching the edge of the solar system was itself living on a microscopic speck inside the cosmic darkness. Voyager did not just show us the solar system. For one brief moment, it showed humanity where we truly lived. And then, after looking back one final time, it turned away and continued into the stars.